Welcome to lesson 4.1, Quadratic Graphs, looking at the function y equals x squared plus bx plus c. In previous unit, we explored quadratic expressions and equations. Now we're going to take a look at the graphs as a function. We're going to start with the most important quadratic function, y equals x squared, as all other quadratic functions are just variations of this one. Mathematics might say transformations of this one. And a good idea when we're looking at a type of graph for the first time is just to explore a table of values. And we want to maybe pick some negatives and some positives if that's appropriate, and we'll see as we go along if it is. So we're going to go y is negative 2 squared. In that case, the negative 2 is in parentheses. So negative 2 times negative 2 makes positive 4. And we can plot that point on the graph. Left 2, up 4. And then negative 1. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1, so right 1, up 1. And 2 squared is 4. So, unlike the graphs that we saw in previous units, it's not a straight line. It's going to be a curve that passes through these points. There's our quadratic graph. The shape is called a parabola. It's a U shape. It does have arrows at both ends. It does not go straight up the page. It still moves here to the left and here to the right. There's a vertical line here that splits the parabola in half, acts as a mirror, same on this side as this side. That is called the axis of symmetry. So it's a vertical line for our base graph here. It's right on the y-axis. The vertex is the most important of all the points that are on the parabola. It's, in this case, any parabola that opens upward, it's the bottommost point. It's always going to lie on the axis of symmetry. That's a vertex. So in this case, for this one, our vertex is right here. Okay, and we're going to kind of try to get used to that. The middle value in the table, 0, 0, would be the vertex. Example number 2, graph y equals x squared minus 4x plus 5. So we can do a table of values for that one as well. We just need to know which x's we should pick. So here's how we're going to know which x's we want to use for a table. We're going to use the formula. This is an axis of symmetry formula. X equals the opposite of b divided by 2 times the a. So let's see if we can figure out what the a and the b and the c are. A is the coefficient here, invisible 1, 1x squared. Negative 4, the coefficient of the x, positive 5. And it's not necessarily the numbers that you see in order, because if this wasn't here at all, just say it said x squared plus 5, this would still be 1. The c is the constant, no x is attached to it. That would be the 5, and this could be a 0. The only one that's not allowed to be a 0 for a quadratic function is the a. A can't be 0. You have to have some amount of x squareds. Otherwise, it's not that U shape. So we're going to use that. We're going to say the opposite of negative 4, so positive 4, divide by 2 times the 1. So positive 4 divided by 2 is 2. So for our table, we're going to have the 2 be the middle x. And then above that, the ones that are smaller, like 1 and 0. And then below that, the ones that are bigger than 2, in order, 3 and 4. Make sure it goes in order. So 2 is going to be the middle x. And then we'll go in order, smallest to biggest. 1, 0, 3, 4. A little bit more challenging in terms of our evaluating is substitute in a 0. Zeros are generally pretty easy though. 0 squared, 0. Minus 4 times 0, 0. Plus 5, we would get 5. We can do that for the other ones. Now, if we have chosen these correctly, you're going to see some symmetry in the table. Notice here, here's our middle one, vertex. These two are the same, and then these two are the same, because these are all evenly spaced here. So if we plot these points, and then fit our curve through, we have our parabola. Now let's see if we can analyze some different features about that graph, about that parabola. What's the vertex? Remember, we can get the vertex from the middle x and y in the table. And as far as a point, if our u is opening up, it's the lowest most point. So we would say it's going to be 2, 1. Axis of symmetry. Well, we can go back, and that's right here. X equals 2. It's a vertical line. All vertical lines have the equation x equals number. Here it is, x equals 2. We can get it from there. X equals 2. In fact, we can even draw it right there, the line that splits the parabola in half. Y-intercept. We might be able to see the y-intercept on the graph. We saw right here where our parabola hits the y-axis. It hits at 0, 5. Now, if our parabola is in this form, maybe we don't even see it. If this is shifted off to the side, one of our points may not be on the y-axis. So anytime you're asked to find a y-intercept of any function, you can always just plug in a 0 for all of the x's. If we do that, 0, 0 plus 5 is 5. In fact, if our function is listed in this form, the c that we've identified earlier, that goes there. 0, c will be the y-intercept for all of our quadratic functions that are listed in this format, which is called standard form. ax squared plus bx plus c form. We're going to be asked for the domain. What is the domain of the function? How far left and right? What are all the possible x values? Well, we can take any number, square it, multiply it by -4, add 5, combine all those. We can do that. There's no issues at all. And if we look at our graph, this arrow is pointing to the left, and this arrow is pointing to the right. So it goes forever left, it goes forever right, which is why our domain is all real numbers. Back from Math 2, you might have seen that as parentheses, negative infinity, comma, positive infinity. It goes towards negative infinity, it goes towards positive infinity. We can plug in any x, is what we're saying. Range, those are the y-coordinates. That's not going to be all real numbers because it doesn't go down forever. So what we can say is, hey, all of our points are here and above. So we would say y is, and that y-coordinate is 1. Y is above 1 or equal to 1, and therefore y is greater than or equal to 1. Notice how that matches that. Anytime the parabola opens upward, it's going to be y is greater than or equal to. Example number 3. Y equals x squared plus 3x. Start by identifying a, b, and c, and then we can use the formula to find our middle x. So a equals 1x squared. B is the number in front of the x. That would be 3. C is the constant, the number all by itself. There isn't one, so that's going to be 0. Now let's do our formula. X is the opposite of b divided by 2 times the a. And if we do the division, we get negative 3 over 2, also known as the fraction negative 1.5. So that would be our middle x. So think about, on a number line, what's just to the left of, and we don't want it, we want this to be our only decimal. So the rest we want to be integers. So So what's just to the left of negative 1.5 on a number line? Negative 2, then negative 3. What's just to the right? Not 0. Don't skip one. It's negative 1 and then 0. So these are the x's that we want to do. Now take a moment. Go ahead and start substituting those into our function. Negative 3 squared plus 3 times negative 3. You can use a calculator. Make sure you use parentheses, especially around negative numbers. Or we can just kind of try to do it on our own. Calculators are often more reliable though. Negative 3 squared is 9. 3 times negative 3 is negative 9. Added together would be 0. Do that for the rest. We should get these values. And then we can fit a nice smooth curve through our points. And here's our graph. Now let's analyze. What's the vertex? Negative 1.5, negative 2.25. What's the axis of symmetry? Remember, that's an equation. Always x equals number. Here's the x coordinate of the vertex. X equals negative 1.5. Y-intercept. We can see it. It's a point. Something comma something. 0 comma 0. Remember when we said 0 comma c, and previously we just said that c was 0. What's the domain? It goes forever left. It goes forever right. It's all real numbers. That will be the domain for all of our quadratic functions. What's the range? Here and above. Y is greater than or equal to negative 2.25. Example number 4. Slight difference here. Let's attack it the same way. A equals B equals C equals. What does A equal? Negative invisible 1. Negative 1. So that's going to change things a little bit. Negative 1. B is 2. C is 2. Let's find our middle x for our table. X equals the opposite of 2 divided by 2 times the negative 1. So negative 2 divided by negative 2 is positive 1. It's going to be our middle x. So now, what's just left of that, or less than that? 0, negative 1, 2, 3. Put them in order. Now we can start substituting in. But you have to be careful, especially if you're using a calculator here. You want to square the x first, and then apply the negative. Or, as A is saying, it really means negative 1 times x squared. So careful with parentheses if you're using a calculator. If we were doing negative 1 squared, we would get 1, then apply the negative. So it becomes negative 1. Plug in a negative 1 here. A negative 1, negative 2, plus 2 is going to make negative 1. Here are the rest of them. 2, 3, 2, negative 1. Make sure you can come up with those numbers. Let's plot those points on a graph. So you can see now, based on our numbers here, that our parabola is going to open downward. That's because of A being negative. Anytime A is negative, the parabola is going to open downward. Anytime A is positive, it's going to open upward. Here's our parabola. Let's analyze the different parts, like the vertex. By the way that we do it, that's going to be our middle x and y. 1, 3. Axis of symmetry. X equals 1. Y-intercept. Okay. So pretending we couldn't see it here, we would say it's 0, C, so 0, 2. But we can see it on the graph, so kind of a double check there. Domain. We can still plug in any values for x. It's all real numbers. Range is going to be a little bit different because now we're talking about here and down for the range. So y is less than or equal to 3. It's going down, so 3 and below, less than or equal to 3. That's it for today. I'll see you next time.